5.3, modeling data with a line of best fit. Determine the linear function that best fits a set of data and use the function to solve a problem. Okay, now for sure, on the exam, you're going to be doing some regressions, right?
Wait for the pencil to get sharper.
It's either sharp or you just gave up, right?
Yeah.
Okay, so any regression you do on the calculator on the exam, and you will likely be called upon to do 2 of them on the exam, and none of them will be linear, right? But we got to start somewhere, so we're just going to practice with the linear. All right, step 1, turn your calculator on. Step 2, if you're likely going to be doing more than one regression, so the best thing to do is to clear out your list. So go second, hit the plus sign. You want number 4, clear all lists, and then you hit enter. Okay, that's just going to clear out the list so you can start over again and do a new regression. You go to stat, and number 1 is edit. And we get this. We are going to put the heights in L1, and we're going to put the hand spans in L2. Okay, so you got the book in front of you. It's probably easier to read off the book than off of here, but whatever. So 165. And if it's 165.0, you don't need to put the 0.0. Now, they're not likely to ask you to do as many, but there could be like 12 points or something, so.
How do you get to the next column?
One thing at a time. So, notice it says there are 15 students, right? So right now it's asking me to enter the 15th, which means that I likely missed one. So I want to go back and check my list. Now if I miss one, it does matter. So that's 4. Okay, 3, 2, 1. So 165, 172.5, 172.5. 57.5, 170, 168.8, 177.5. 182.5. 72. Oh, I missed a 165. So 165 and 170. Okay, so now I've verified. Now, so to move over, just right arrow takes you to the top of L2, and now I'm going to put in the hand spans. Uh, 21.1. 17.6. 16. And it doesn't hurt when I'm putting in the 22.5 just to make sure that it's beside the 177.5, right? Just making sure that you're getting the numbers in the right place. Wait, not one is. I'm just going to leave that. 23. Okay, wait, I got a few mistakes there. If I'm looking back up, that should be a 25. Then 23, then 20.2, 21.1, 20.7, that should be 0.7. 20.7, 16. Okay, now one thing you should do on the exam, any exam, test, whatever, go back through the list and check your numbers, right? It's easy to hit something. You're supposed to enter 17.5 and you enter 175. If that happens and you just go ahead and do the thing, your answer is going to be wrong. If it's numerical response, you're going to have no idea your answer is wrong. If it's multiple choice, you're going to have a shot because you're going to get an answer that isn't there. Right, and then you go back and look. But always go back and check through the lists, okay? It won't take that long. You have 3 hours on the exam. It's not going to take that long to just go back and check through the lists, right? And they probably won't have 15 things, but if they do, I'm not going to worry too much about checking because if, 15 of us are doing this and I come up with a different answer than most of you, then I know there's a mistake there and then I can check it over. All right, now we want to do a linear regression. So we hit Stat. We go arrow over to Calc. LinReg is number 4, so you can either hit 4, okay, it'll bring up LinReg. Now, depending on the calculator, how many see a screen that looks like this? Nobody. 1 or 2. Okay, so depending on the calculator you have, if you have an 84 plus, you can get an updated version of the firmware. Okay, so you can just do that online. You can go to the TI site and just say, how do I update the firmware on my TI 84 plus? And if you have the connecting cable for the calculator, then you can do that. And then your screen will look like this. If you have an 83 plus, then what you're seeing is LinReg, open parenthesis, right? And what you want to do then is you can just actually, here's what we're going to do. So it defaults to list 1 and list 2. So I'm just going to hit those. There is no frequency list for this, but I want to store the regression equation. So if you're looking at a calculator that looks like this, you want to arrow down to store reg EQN. If not, then here's, it says linreg. Here's what you're going to do. You're going to go vars, hit the vars key. It's right here. You're going to arrow over to yvars, and you're going to hit enter twice. And it's going to put a y1. So either you're looking at this, or your screen says linreg y1. Okay, I'm going to hit enter to go to calculate, and I'm going to hit enter to do the calculation. And if you've got the y1 sitting there, right, because you entered, then just hit enter, and you should see this. Yep. Been there, done that, watch the video. No, seriously, I just went through it. I'm not doing it again. Okay, and the reason the video's up because the half of you that don't have calculators or aren't following along, but are going to get yourselves lost doing this, you must be able to do regression equations. There will be 2 on the diploma. You need to get practice with it. You need to bring your calculators every day from this point forward if you don't have them. Okay? And if you're not here, then just watch. Don't worry, we're going to do another one. We'll get a second chance. Okay? But going through the video also, you can pause it and look and see. And little blue glowing dots will appear on the screen where I'm doing key presses. Okay? So you can just pause it at that point and say, okay, now let me watch this, right? Okay. Everybody got this for numbers? Yeah. Okay, good. So it's probably right. We put the regression equation into y1. What this is going to do for us is it's modeling basically based on your height. I mean, obviously, the taller you are, probably the larger your hands. And so somebody has measured height and then hand span, right? And we're seeing, okay, does this actually fit? Does it? So let's find out. So one way to do that, we're going to go to Window, okay, because we're going to graph this. And we're going to adjust our window. So we can see the heights. Your L1 is your X values, right? So we can see we're going from 153.8. So maybe we'll start at 150. And we'll go as high as, goes up to like 180. Let's go to 190. And we could go by fives. Okay, so 190 and 150 are 40 apart. Going by fives, we'll get 8 ticks, which is easy enough to see. Your Y min, so minimum hands, but what do we got, like 16? So let's say we go 50. And the maximum hand span, we got like 25, so let's go maybe to 30 by fives. Okay, now we put the equation into y1, but if we want to see the points that we plotted, here's how we're going to do it. You go second function y equals. Okay, second y equals takes you into the stat plot menu. Okay, you hit enter on number 1, you hit enter on. Okay, and that'll turn it on. That's all we want to do is just turn on the stat plot, right? Which allows us to see the data we entered. Okay, then you can hit graph. So the first thing we get is the actual points, right? So each one of these guys here corresponds to one of the points here. Second thing we get is the linear regression, right? The line of best fit. You probably did this in science like years ago where you plotted them yourself and then took a ruler and just tried to figure out, right? But this is doing it mathematically. It's calculating that line of best fit, right? Now there's one other thing that we can actually look at, and that is how close does this regression fit? So to do that, we need to turn on diagnostics on the calculator. So here's how you turn on diagnostics. Hit the alpha key, and then you see the little D there. So when you hit alpha, it's now going to do keys that are in green. So I want this one, which is D. Okay, wait. Alpha, D. Come on. Damn, it doesn't work on this calculator. Oh wait, sorry. Don't want to do that. You want to go second catalog. My bad, wrong order. So go second function catalog, then do the alpha D. Okay, second function catalog down here by the 0, right? That gives you a list of all the functions in there. That used to work. Okay, you want to scroll down till you see I think if you hit alpha D, it might jump to the D's. It didn't on this one, but. So I want to go to diagnostics on, so I just have to kind of scroll down till I hit diagnostic on. It's going to take a while. Luckily it's a D. Oh, there's got to be an easier way on this. Okay. So did alpha D work for you? Did it go to the D's? No? Yes? Okay. Not, I don't know. Okay. Diagnostic on, hit enter. It comes onto the screen, now hit enter again so it actually turns them on. So now my diagnostics are turned on. You go, okay, what does that mean? Well, okay, now let's go back to stat, over to calc. Number 4, I want to do linear regression. Ooh, I'm going to show you how to get the y1. Pay attention this time. So we're going to arrow down, store regression equation, hit vars, arrow over to y vars, hit enter, it'll put a y1 in there, okay? Hit enter to run it. Okay, now diagnostics on gives you this. And it gives you an r squared value. The r squared value, if it's really close to 1, then it says this is a really good fit for the data. This is not really close to 1, so this linear regression, this line is not really a great fit for the data. Okay, now again, we can hit graph just to look at it. Yeah, I mean, you can tell, right? It's all spread all over the place. But there is a correlation that the larger this goes, generally the larger this is, right? which makes sense. We know that you do it with foot size as well, right? I mean, larger people are going to have bigger feet, and they have a larger hand span. So now, let's see, did they ask us to do anything with it? All right. Where did we So, what linear function best fits the hand span and height? So we could write that out. Plot the data, use a ruler. We're not doing stuff by hand here. Use technology to find the line of best fit, a straight line that best approximates the trend between a scatter plot. So the scatter plot is all the blue dots, right? They're the points that we entered. And when you plot those, it's called a scatter plot because they're scattered on the plot, right? How does your equation of the linear regression function compare with your equation if we didn't do a part C? Collect 15 more data points from here. If we collected more data points, we might, get a tighter fit. Regression function, a line or curve of best fit, developed through a statistical analysis of data. Okay, that's what's happening there. Use technology to determine a linear model for continuous data. So, 1 hour record is the farthest distance traveled by bicycle in 1 hour. The table below shows the world record distances and the dates that they were accomplished. Okay, so we're going to put that in our calculator, right? So, first thing, second, mem, number 4, clear all lists. Okay, so let's get rid of the list. You go to stat, edit. Okay, lists are cleared. We're going to arrow over to L1. So we're going to enter the years, 1996, or 996, 1996, 1998, 1999, 2002, 2003, 2004, 2007, 2008, 2009. And now the distances, 78.04. 79.14, 81.16, 82.60, 83, 2, 84, 2, 6, 7, 2, 6. Okay, now you want to make sure your lists are the same size, okay, which means you didn't miss something. You want to go back through and just double check. I'm not going to worry too much here again because if we're all getting the same answer, then we probably didn't all make the same mistake, right? We entered them right. Let's just go look at the scatter plot. So before we go to the scatter plot, we got to adjust the window, right? So we're going from, let's say we go 1990 to like 2015 maybe, by 5s. Right, I'll just expand a bit because if we want to do an extrapolation, if we want to say, hey, if this continues on the same path, then this is what the numbers will be. And let's go 70 to 100 maybe. To 100 by 5s. Okay, now if I hit graph, we're just going to get the scatter plot, right? So we're looking at it. We'd say, that's pretty good, right? Like, I could draw a fairly nice line through those, okay? So it does look like it's linear, right? And we have to decide that. And sometimes we're doing regressions and we'll say, well, try linear regression. Does it fit a line, right? And with the diagnostics on, we'll get that. Does it fit? Try a quadratic. Which one's better? Which one has the higher R squared? Try a cubic. Again, which one's better? Which has a higher R squared? Okay, let's run a linear regression. So we go to stat, over to calc. Number 4 is linear regression. Okay, we got the L1, L2. There is no frequency list. Store regression equation. So in other words, to get the y again, vars, over to y vars, enter, takes you to y1, enter again, there's y1. If you've got the other calculator, just go Linear Reg, and then put in the y1. Okay, and then just hit enter, which is the same as this. Okay, r squared, 0.96. That says this fits pretty well on a straight line, right? Straight line is a good fit for this. Graph, now we'll see the line. Yeah, it's pretty good, right? I mean, the only thing that's really out is this one here is a little higher than we might have expected at this point, because it's been increasing. So use technology to create a scatter plot. Yep. Interpolate a possible world record for the year 2006. So you notice there is no data for 2006.
My calculator doesn't dots.
Then you haven't turned on your stat plot.
How do I do that?
Second y equals, enter, hit on, then hit graph. Okay, so to interpolate, what it's going to use is the line, right? So we have to put that into y1. That's why whenever we run a regression, we always say put it into y1. So it'll draw the line. Okay, so you go second, calc. So this time I want to give it an x value. The way we give it an x value is we go second calc, number 1 is value. Then it says, all right, what x value do you want? So we say, okay, I want 2006. And then it shows you here, hey, here's the point that it would be, and the value is 86.38 kilometers, right? I assume that's kilometers. Yeah, it can't be miles. So 83.68 kilometers, right? Compare your estimate with the actual world record distance of 85.99 kilometers in 2006. 86, a little bit above 86. It's a few hundred meters off, right? So not bad. It's a pretty good fit. And here's Carmen's solution using, so I don't even know what kind of graphing calculator that is, right? But and I think they also show it on a spreadsheet, right? I mean, obviously we're not using any spreadsheets because you're not going to have access to a spreadsheet. Now, the other thing you could do is you could say, in which year would you likely have had a distance of, oh, let's say 80 kilometers, right? So this time I'm going to give you a y value, so you have to go to y equals, put in 80, and then hit graph. And what we want to say, all right, so when would it have been 80? And then we want to go second function calc, and we want to find the intercept. We want to find where do those lines cross, right? And what's the y value? So what I do is I move down this line till I get to about the point of intersection. And then just hit enter 3 times. So it's asking you, what's the first curve? And you notice it's showing you y1. And you hit enter. What's the second curve? And now it goes to y2. But we're already there, so you hit enter. And it says, give me a guess. And you say, well, we're there. So 1998.5, right? So like halfway through 98 is about when the record would have been 80 kilometers per hour. Use linear regression to solve a problem that involves discrete data. Matt buys t-shirts from a company that prints on t-shirts and then resells them. But buying the t-shirts, the price Matt pays is related to the size of the order. So here's different orders, and there's the cost per shirt. So we're going to run a regression, right? First step. Second, mem. Number 4, clear all lists, hit enter. Right? Wipe it out. If you forget to do that or how to do that, just reset your calculator. On the exam, if you run into any problems, sometimes like L1 isn't there. Like you it just says like L2, L3. Reset your calculator, okay? And that'll fix that. Okay, stat. Whoops, edit. Notice they're clear. Move over to L1. Put in 500, 700, 200. So we're getting the order size. 200, 460, and 740. arrow over, put in the cost. Okay, check and make sure your lists are the same size. Here's what's going to happen if your lists aren't the same size. Let me just throw in a value there, okay? So don't do this. My lists are not the same size. When I go to stat, calc, whatever, we're on a linear regression, to calculate, you're going to get error dimension mismatch. Now yours might just say error invalid dim. What that means is you've got lists that are different sizes, right? This gives you more information. Let's say quit, go back to stat, edit, and just take that one out. Okay, so if you ever see dim mismatch, what it means is that you've got more things in one list than you do in the other, and it can't run a regression. Okay, before we run the regression, first let's go to y equals and just clear out what's in there. Clear. Let's go set the window, so we know our x's are like 200 to 7, so let's say maybe 0 to 1,000. Okay, by hundreds. And our y values go up to about 520, so let's go like 0 to maybe 6 by ones. Okay, now if I hit graph, we're just going to see the points, right? That's your scatter plot. Okay, those look like they're on a pretty straight line. So we can run a linear regression. And what it says is basically the more shirts you buy, the lower the cost. Remember, this is the x value. So the L1 is your x's, L2 is your y's. So as your x's go up, your y's go down, right? Cost goes down with the number of shirts you buy. So we go to stat, calc, linreg. Okay, if you have this screen, you want to go to the store regression equation, vars, over to y vars, enter, enter. And otherwise, you're saying linreg, then y1. Hit enter, calculate. If you're writing out the equation, right, then you write it out. Don't write out y equals ax plus b and then copy down what a is and copy down what b is. You need to write this out as y is equal to negative 0.007.
Mr. Yanover,
Yeah.
my calculator just rounded, so it's 6.51 negative 0. Or negative 0.
Anybody else get this? Or was yours different?
Mine's rounded.
Yours are different?
It's that rounded.
6.
0065.
0065. All right, let me just take a look. 500, 700, 200, 460, 740, 3 1/4, 1.95, 5.2, 3.51. Oh, 1.69. Here we go. Oops. That's why you check, right? Because it's off. Okay, and that's why you guys say, hey, numbers are off. Okay, so stat, calc, 4, yeah, bars, y bars, enter, 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 enter. Better?
Yeah.
Ah, okay. So negative 0.0065 and then 6.5. Okay, anyway, that's how you would write it out. Okay, we've seen this guy, and you know r squared is 1. This is a perfect fit. Okay, like they all lie on a straight line. Nobody's out by anything. So if I hit graph now, you're going to see it's a perfect fit, right? It goes right through there. So if he orders enough T-shirts, you can get the cost down to 0. Does that make sense? No. Somewhere there's a low price, right? Like it's you order 10,000, I'll give it to you for this much, but below it doesn't, above that quantity, it doesn't matter. I'm not dropping the price anymore.
Do we have a quiz on Monday?
No. Use the linear function to extrapolate the size of the order necessary to achieve a price of $1.50. So $1.50 is, cost was on here, right? It's like 1, 2. So $1.50 is about here. So $1.50 is about here. So what we do is, I want the $1.50, so we go to y equals, go down to y2, put in 1.5, and then hit graph, and it'll draw the line right across where I drew the line. You gotta know where to draw the line. And then we want to find the x-coordinate of this, right? Because that'll be how many t-shirts. So second, calc, intersect. And again, just move down to the point of intersection, then you can just hit enter 3 times. So, whoops. Okay, 1, 2, 3. 790. Excuse me, $796.23. Or sorry, that's shirts. 769.23 shirts. So probably 769 shirts, you'd get that price, right? Maybe you'd have to go to 770, right? But you'd have to go to the next higher number of shirts in order to get that price. Again, so they're showing math solution and blah, blah, blah. And it says, I need 770 shirts. You can't order a fraction of a shirt, so it's rounded up. Okay. At that point, you'd probably just be asking them and saying, what's my, I mean, no, who's going to order 769 shirts, right? I mean, you're going to go to the next highest one. But you might be phoning them and say, how many shirts do I need to order? And they could say 769 or 770 or whatever. Key ideas. A scatter plot is useful when looking for trends. Okay, now we will be doing not so much linear, right? That's boring, and that's also earlier grade stuff. We'll be doing quadratics. Yes. So, knock it off.
Just wants to.
Okay, we will be doing quadratics and cubics, and sometimes it's hard to tell which one you're going to use. Okay, because the part of, you know what a quadratic looks like, right? So a quadratic looks like this. Let's say it looks like that. Now, a cubic could look like this. Now, these guys, if you're only looking from here over, might look the same, right? So you're just saying, it could be a quadratic, but it could also be a cubic, right? And maybe what we're seeing is just this part here. And they're kind of identical, right? Or really close. So you run a quadratic regression, you look at the r² value, right? Diagnostics on. And then you do the same with a cubic, and you pick the one that's got a higher r². And say, well, this is probably better modeled by a cubic than it is a quadratic. So plotting, putting the points in first, setting your window, and doing a scatter plot is a good first step, right? To decide, well, what does this look like? If points on a scatter plot seem to follow a linear trend, there may be a linear relationship. Need to know. Points on a scatter plot follow a linear trend. Then you can use technology. You can do a linear line of best fit can be used to predict values. Now, even the same deal. So the scenario I drew, right? Like there's a quadratic, and there's the same thing, but it's a cubic, but it does that. And then here's the same thing, but it's a linear. So if you're only looking from here over, you don't know which of these it is, right? Could be linear, could be quadratic, could be cubic. So on Monday, we will be doing the quadratic and the cubic regressions. Lag there. Okay, and then using the r² value to help us decide which is the better. On the diploma, they're going to tell you which one to use, right? They'll say, run a logarithmic regression or do an exponential regression to do blah, 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 right? But we still need to be able to determine or decide which of the ones we want to use.